Once again, Dr. Ajay Sattu is Senior Manager at Amcor in Automotive Product Marketing. He's focused on automotive electrification, ADAS, and infotainment product marketing and strategy. Ajay holds a PhD in electrical engineering from the University of South Carolina and an MBA from the UCLA Anderson. Go ahead, Ajay.
Good morning, good afternoon, and good evening. Thank you for this opportunity. I'm delighted to participate in this MEPTEC event to share Amcor's initiatives in Industry 4.0 and how automotive unit level traceability is part of this initiative, right? So again, thanks for the introduction there. My name is Dr. Ajay Sattu. I'm part of Amcor's product marketing team, leading the automotive segment. Yes, so the outline of my presentation will start with a brief introduction to Amcor and what role Amcor plays in the semiconductor supply chain. Then I'll introduce a few slides on Industry 4.0 initiative that we have at Amcor and our ideology behind this thought and framework that we use. Then, I'll introduce unit level traceability, which is the main topic of the discussion. Again, it's motivation, why automotive OEMs and the tier ones and the entire supply chain looks at it in terms of implementing it and what's the value proposition Amcor brings to our customers. Now, a brief introduction of Amcor. Amcor was the pioneer of OSAT business model with more than 50 years of experience in the industry. And for those who are not familiar with the term OSAT, OSAT stands for Outsourced Assembly and Test, right? So that is, we are primarily responsible for packaging and test. And for the first time in our history, we have achieved 5 billion net sales last year amid COVID-19 pandemic. We have more than 30,000 employees globally and with footprint in 11 countries. And we serve several end markets such as communications, consumer, and automotive. Now, based on last year's performance, Amcor's number one end market is communications, and this was primarily driven by cell phones and connected devices. Now, consumer was our second largest with 24% of our revenues last year. And again, this end market is driven mainly by wearables, AR, gaming, etc. And the third one there with 20% revenue is automotive and industrial. Now, we tend to combine industrial into automotive. And, it's essentially maybe only 10% of what we have in that particular segment. So most of it is automotive. And again, the growth here is headlined by application segments such as ADAS, infotainment and cluster, and electrification. Now, the rest is in computing, which covers high performance compute, AI, and data center markets. And finally, allow me to share some key facts about Amcor Automotive. We are number one OSAT by revenue with nearly 1 billion net sales going back 2019 and just under that last year due to COVID-19 pandemic. And we have 11 automotive production locations globally, supplying 40 different semiconductor package families to our customers. Now, given the safety and mission critical nature of the applications we enable, zero defect quality focus is a must for us. And in the next few slides, let's take a look at what Industry 4.0 initiative is all about at Amcor. So what is Industry 4.0, right? I mean, by definition, we say that it refers to a new phase in industrial revolution that focuses heavily on interconnectivity, automation, machine learning, and real-time data. So Industry 4.0 connects physical production and operations with smart digital technology, right? And we can, as we have seen and heard, there are again 4 distinct industrial revolutions that the world has progressed through, right? The first industrial revolution happened around late 1700s and early 1800s. During this period, again, most of the manufacturing evolved from focusing on manual labor to steam-powered engines and other types of machine tools. Now, in the early part of 20th century, the world entered into a second industrial revolution with the introduction of steel and the use of electricity in factories. Starting in late 1950s, a third industrial revolution emerged by incorporating more electronics and also introducing computer technology into factories. Now, finally, in the past few decades, a fourth industrial revolution known as Industry 4.0 has emerged with the help of digital technology and interconnectivity. Now, Industry 4.0 offers a more comprehensive, interlinked, and holistic approach to manufacturing. And at Amcor, the at Industry 4.0 is through 8 technology pillars, right? And that sort of forms our framework how we implement Industry 4.0. Now, some of these are autonomous equipment or machines we use in assembly and test, or industrial IoT, universal system integration, AI, big data analytics, cloud computing, cybersecurity, and also simulation of manufacturing capabilities and so on. Now, going a little bit more specific into each of the 8 pillars, and also a broader picture of the framework at Amcor, we have identified 20 different types of projects or mechanisms that aligns with these 8 technology pillars that we have adopted. Now, depending on the needs of a particular manufacturing line, whether it's consumer versus automotive, and also by different package types, our factories could be pursuing anywhere from 3 to 6 major projects that are listed on the right side of the chart there. Again, this table shows the key projects there, right? So, and for example, the topic of my discussion, ULT, unit level traceability, that falls under the 3rd pillar, which is the universal system integration. While that may be the case, ULT, and for most of the automotive centric processes at Amcor, we also rely on some of the other mechanisms, right? And that could be AI, machine learning, that could be autonomous equipment, data analytics. So this is aimed, especially to provide best automotive quality and also have that end-to-end visibility for our customers. While that may be the case, how do we value this, Industry 4.2 projects, right? I mean, we measure the smart manufacturing successes using, various key performance indicators, right? As you can see on the screen there. Now, all projects that are approved under our Industry 4.0 program will be tied to more than one of these key performance measurements, right? And again, that could be quality to improve yield, productivity of the employees, manufacturing cycle times, and cost as well, right? I mean, asset utilization and cost. And finally, let me introduce one slide on ULT before we jump into motivation of why we require traceability in automotive segment. So, fact that again, Amcor is #1 OSAT. Our customers have high expectations around what services that we offer and what features we offer in automotive, and ULT is certainly one of that. In most cases, they need very unique Unit 2D barcode that provides process information, material information, and equipment history at every process step that the product goes through. It's not just that, they also require real-time retrieval of information. So it's essentially, I mean, we can look at it this way, right? I mean, they have all of these data dots and they want to connect all of the dots in real time or on, and that's essentially what ULT is all about. And in the next slides, let me give you a bit of background on the motivation for traceability at the industry level and how that has essentially driven down all the way to the entire supply chain. Now, in terms of motivation for traceability, I mean, again, we have to look at it from what are the growth areas, what's happening at the industry level, right? So, again, we have seen this, heard several times from various experts that again, growth in automotive semiconductor market is primarily due to 2 areas, right? So, the first one is ADAS, and again, which stands for Advanced Driver Assistance Systems, and the second one is electrification. Now, in the past, ADAS meant more anti-lock braking, traction control, and electronic stability, etc. that we these features that we have in the car. But nowadays we have seen newer applications emerge, right? And these are adaptive cruise control, could be lane departure warning, could be driver monitoring that some of the car manufacturers offer in the newer vehicles. And all of these newer applications are enabled by combining various sensors, processors, memory, and also controllers. Now, traditionally, I mean, one could think that, okay, all of these different electronic components or semiconductor components were put together at a PCB level. But now what we have seen is some of these chip functions move to the component level in terms of integration, right? So, if you talk about some of these ADAS processors or vision processors or ADAS central compute, where we see that processors are being integrated with memory at the chip level, right? And you also see some of the sensors, integrated with ASICs in the package itself. So again, a lot of these trends are, multi-chip modules, and it's not just the active devices, but also, passives integrated into the package as well. But I mean, that begs the question, right? I mean, how does this relate to automotive traceability? And, traceability in general, again, this is not new. I mean, in the industry at large, automotive industry at large, that has been existent for a long time. Now, in the past decades, we have seen mechanical and electronic modules were used to be marked with 1D or even 2D barcodes, and sometimes even tagged with RFIDs, right? So when the traceability was first introduced in automotive industry, it was more from a defensive mindset to minimize recalls. But now we can see that the entire industry has embraced this at all levels of supply chain, right? So, for a moment, let's consider the complexities of modern age semiconductor supply chain, which includes design, fabless design houses. You have foundries, you have IDMs, and also OSATs, with so many actors involved in this product supply chain. It becomes quite challenging, right? So I mean, do we have standards to rely on? So that's where we have seen semi organization to take a proactive approach in the last several years. The Traceability Standards Committee has been working on a framework across the entire supply chain. And going back to 2019, SEMI has introduced a T23 standard, that mandates a unique device ID that is required for wafers to multi-chip devices that goes through the entire supply chain. Now, that was on the one side of the device ID, right? I mean, we do expect more standards to come out for the entire assembly and test, once the packaged IC side of things. Meanwhile, SEMI has also been looking at continuing standardization efforts for device security and also anti-counterfeiting by sharing the data via blockchain technology. Further looking at the motivation, in most cases, this arises from either warranty, whether that's pre-failure concerns or pre-delivery failures, right? So to further understand the impact of warranty claims and the role of semiconductors, let's look at the charts that I have here on the screen from the left to right. For example, if you look at the data published by Semiconductor Management Group at BMW several years ago, annual warranty costs, nearly 20% of that is around electrical and electronic modules, right? And of which, again, 23% is active and passive devices. Within that, majority is semiconductor devices, right? So as you go from the left to right, what you can see is the type of failures and also at what location these failures are happening. And, assembly and final tests are more than 50% of these failures, right? So from a quantitative point of view, we can say that for every $1 of warranty cost that an OEM spent on warranty, nearly 4 cents can be attributed to the failures of semiconductors, right? So and from the industry, when you look at the latest data that we have, one OEM warranty report says that approximately 49 billion was actually paid out as claims in 2019 by just the top 12 car companies, right? So, and this number will only increase in the future with increased complexity of new cars and also higher semiconductor content per car. And in terms of reasons for unit level traceability, we can understand the financial impact is clear, right? But I think it goes beyond that. It also results in reputation loss for the suppliers, right? And also puts significant stress management. I mean, when you automotive OEM's perspective, if there is a safety related failure, they require the suppliers to do an 8D in less than 10 days. Right. And, and again, as I said earlier, number of semiconductor components increasing, there is an increasing chance that the failed component is actually a semiconductor, right? So in this case, component traceability can quickly isolate defective batches and to also figure out what is the root cause and also if there is a commonality that we can work from, right? So automotive components are, again, marked for traceability in the past, and they currently do as well. But we now see that trend extending to automotive ICs as well. Now, in addition, what we also do at Amcor is to use this process as an improvement tool to collect data and also to improve our own processes, right? So let me talk about what ULT Amcor in the next few slides. So Amcor's ULT provides information from an assembled IC, and that could be done through 2D barcode marked on top of the device, as shown on the on the left there, right? So again, we have two different packages here. The top one is what we call it a dual lead frame package, which generally houses logic, EEPROM or analog chips, right? The second one is a BGA package, essentially for high-end microcontrollers in automotive. Now here, the type of data that we collect may include die information such as wafer ID, die position, the XY coordinates of the die, substrate, and also lead frame strip information. And it also goes beyond that, right? I mean, we also gather information relevant to equipment at various steps in the assembly and test process. Now, ideally, ULT could be mandated as part of an automotive process flow. However, we still see this as an option for some of our customers, and that could be a cost-driven concern, right? So, what Amcor does as part of this service is to not only collect data, but we also transmit that data to our customers, either real time or on demand basis. So let's look at few use cases to give a better understanding of how ULT can help customers and industry at large. So assume that we the package that we just looked at in the previous slide, right? So let's assume that you have this BGA form factor package, and that's used in ECUs in a car, right? So how ULT could help in case of failures is that by detecting if there is a commonality or if these are separate instances. And that is done again, by looking at the 2D marks on the package. Now, suppose you have two field returns, right? And and it has been determined that a particular IC has failed in the end application. Now, an automotive OEM or a tier one can quickly scan the 2D barcode on top of the package to get die and also the substrate information. Right? I mean, these are essentially the two main sources of causing the failure within the die. Now, in this case, we can see that from the table there, both of these units have come from the same wafer, right? At least that tells us that, hey, there is some commonality that we can work from, right? And so certainly, I mean, this helps in diverting your 8D efforts in the right direction. Substrate here, again, was not the culprit, right? So, I mean, that tells you that, hey, by looking at the data and your data analysis, maybe, the 8D challenge that you have from a supplier perspective to finish it in less than 10 days, ULT could certainly help you to, get to a quicker response back to your end customer. Now, let's look at a different use case, right? So, and again, in the previous case, we have looked at maybe two semiconductor packages where you actually can use a 2D barcode on top of the package, right? So what if you are in a situation, a certain package prevents you to put a 2D barcode? So what would you do? And what could be such an application, right? So could be a MEMS sensor, for example. In these packages, we have ASIC integrated with the MEMS or the sensor die. So again, this is a multi-chip module, right? So, and again, from an end application perspective, that could be an exposed die for temperature sensing or an optical sensor with a clear window packaging, right? So here again, the challenge is the top of package cannot be barcoded. So we, and usually these packages are so small, we may not even have enough space to put a 2D barcode on the laminate. So what would you do is to check these, what we know is when you break it down, you look at that you have an ASIC die, you have a MEMS die. ASIC die can be read electrically, but the MEMS die cannot be, right? So for the automotive product, what we do is we collect all of the pairing information of the wafer IDs, coordinates of each die, and also the substrate location, the substrate, right? Substrate information. So later what we can do is you take the ASIC electrical data and you can correlate that with the MEMS die and substrate information. So essentially, even if you in situations where you don't have a 2D barcode on top of the package, ULT still helps you to have that visibility into the entire supply chain. Now on to a little bit more complex case, right? I mean, SIPs. Now for system in package products, it's not just a single die or two die. We are talking about multiple die and could be even packaged packages, products in packages that you combine with discrete SOCs and passives, right? So in such a complicated SIP products, ULT is not only must, but even for us to implement it in the factories, it is quite complicated. So what we end up doing is we use RFID cards that we assign to each of these assembly lots to track the product through the assembly process, and so that at least we make sure the product flows through the right manufacturing flow. Now at the unit level, what we do is when we take the substrate, we laser emboss that with a unique 2D ID serial number for each of the modules, right? So now, and as it goes through to the process flow, we collect ULT data at key process steps, and that provides full traceability of the module assembly. Once all the components are placed on the substrate, the units go through a reflow furnace where the components are soldered. And beyond that, we have optical inspection, automated optical inspection, and also automated X-ray inspection. I mean, one could wonder why would you need both? In cases where you actually have memory packaged in wire-bond BGA type of form factors, you would not be able to look at whether the soldering is done properly, right? So you would then depend on automated X-ray inspection to make sure that the solder joints on the BGA components is done properly. And then finally, units will go through open shot tests where they are again individually tested and sorted. So in terms of Amcor's proposition, what do we provide to our customers, right? So let's take the same complicated SIP example that we just looked at, right? So and again with the amount of data that we could collect and report to our customers in general could be 44 different data elements, right? And what you can see on the screen there. Again, there are too many to discuss here, but broadly you can say that these are segmented into wafer lot details, could be die attach, chip attach, and wafer level packaging information, and also laser marking details, right? Now, when you look at it, is that it? Can we look at anything else? I mean, beyond this, sometimes our customers also ask for material information that can also be captured in the ULT process, right? So on information such as supplier information, a supplier name, batch number a particular material could be coming from, supplier lot number, and also manufacturing data. So in the end, it's just for them to provide this end-to-end visibility into each and every process that the product is actually going through. And we have seen increasing requests for traceability from our customers in the last year or so, right? In the last several years, I would say. And and interestingly, we have seen that from automotive originally, but now I think more and more this has been fanned out to some of the other market segments as well. And in terms of our capability catalog, and again, historically, our capabilities varied by package family and also the factories where some of these were offered. And however, Amcor has been trying to develop a standardized capability to implement it across the product lines and across the factories, and also a standardized reporting of the data to our customers as well. And again, ULT, it's not just for the products in HVM, but these could also be used for data mining, for engineering lots as well. A ULT service includes data delivery, as I said earlier. And again, most of our customers, what we have seen is that they sync the data with their own internal information in their systems, right? So, and again, these are done through SFTP, and that can be done again either daily, weekly, or on-demand basis. And in terms of data retention for automotive, most of our customers require us to provide up to 15 years. And for non-automotive products, that could be up to 5 years. Now, let me talk about some key attributes, how ULT helps our customers. So strip marking and wafer level packaging, and again, these, in terms of, the processes that we use for these, and they go through the entire process flow, is that they're making packaging and the final test kind of similar to a wafer fab processing, right? In that strips are treated as wafers in the fab. In a wafer fab, one way of tracing is to use an identifier, which again could be a mixture of numbers and alpha characters to capture the data. And the second is a map, right? And that essentially tells us where items are given their identifiers, where the dice are given their identifiers. The strip ID is a relatively new standard from SEMI. The standard is T9, which defines 22 characters in a 2D data matrix code, right? Which is typically, again, laser scribed onto the surface of the strip, as you see at the bottom of the on the right side bottom of the screen there. And again, there are several benefits of doing doing this, right, in ULT. What it does is it prevents strip level product mixing after mode process is done. And also, it can generate individual output maps for each lot per assembly process. And also, what you can do is to integrate the AOI and sample open short test data with your die data. And currently, what information is put on in a strip map is also defined by SEMI. But what more and more, I think, from our customers, and what also makes sense from our perspective is to combine these maps with the data, which includes defects found at AOI and open short test, right? So that provides a very comprehensive view for our customers. And while we looked at the 2D strip marking, I mean, if you were to think about 2D code on the package itself, right, on the unit itself, and again, that helps you to track the location of a specific unit on the wafer or the strip, right? And again, this is especially beneficial if you look at from advanced nodes implemented in automotive today, right? For example, whether it's discrete SoC or a multi-chip module, one could use the data gathered from the die traceability study, any yield and yield and defect breakdown or impact of bill of materials on the die performance. And if you were to go back to advanced nodes for a minute, right? I mean, in the past we have seen that automotive adopted advanced nodes probably maybe 6-8 years later, but now we see this gap reduced to a point where it's almost simultaneous implementation in consumer and automotive areas, right? So certainly die traceability can help provide data, such as maybe early life failures of an SoC in a burn-in, etc., right? So by using this tracing information, one can find if there is a location dependency across the wafer. Maybe certain areas of the wafers has more reliability failures than other sections, right? So certainly, I mean, we do see that it's not just to provide the end-to-end visibility, but it's also to help our customers provide the data in a way that would help improve their own processes in the end. And while I've touched upon the flow and how the system works at Amcor, now let me say this in my closing comments, right? So again, Amcor's ULT platform, essentially it could potentially lead our customers to realize some of the same benefits to, such as improved issue management and also security. But at the same time, we also like to think that, the ease with which, our customers and us to go look for the data and also diagnose a single die across the entire manufacturing lines, that maximizes our return on investment, right? Whether it's we are looking at for data mining or whether you're trying to find source of a problem, it's absolutely helpful. Now, in addition, we also see that extending ULT capability is not only as a risk mitigation strategy, but Amcor can again effectively prepare a response whenever there is an inflection point that could come from our customer side, right? So, with that, I conclude my talk and open for questions.
Well, thank you very much, Ajay, for your presentation. And I would remind the audience that there is a button marked Q&A. You can press on that, type in your question, and I will pose that to Ajay. I have one for you. I think that you've demonstrated that Amcor has 100% unit level traceability through every process, and you've gathered the history on every component. I suspect that your customers are using that information primarily for tracking any excursions, issues, and heaven forbid, any possible recalls that may be required. Do you know to any extent that they are using this indeed for supply chain security, any assurance that there aren't tampering or counterfeit devices entering their supply chain? And do you know to what extent they are leveraging your 100% ULT systems to ensure that there is no nefarious activity in their own supply chain.
Sure. Yeah. So from in terms of whether we have ULT across all of the products, I would say we have most of the products at Amcor, right? So, and in terms of what data, as I've talked about earlier, it does provide that end-to-end traceability for our customers. So they certainly can look at whether someone would provide you the or for example, let's look at it this way, right? So let's say you have a design house that does the product at a foundry, and then that product is actually it comes to an OSAT, right, for assembly and test. So in that case, design house would be able to look at all of the data where the product has gone through, right, from foundry all the way to an OSAT. So certainly they would have the data to look at, but I mean in terms of whether they are looking at to understand if there is any counterfeiting, I think at this point it's probably only in the front end or in the fab process, right? I think Semi has a standard that they released back in 2019 that sort of mandates that a unique device ID be there that helps you to identify if there is any counterfeiting that's happening in the supply chain. Now on the assembly and test side, I'm not aware of any specific standards, but essentially what we do on our end is that especially for automotive, what we do is that some of these lots have specific RFIDs, right? So when it gets checked at a particular step, it ensures that the right bill of materials are used, or the right lots are being processed with the right material set and so on, right? So I wouldn't say it's more as an act to, let's say, prevent counterfeiting, but I would say that we ensure that we use the right processes for our customers, right? So even if something does not get caught in your open shot test or your final test, certainly, I mean, you'd be able to look at that information and say that, hey, you know what, there's something wrong with this lot, right? So not at the assembly and test level, but I think certainly there is some mandates and standards out there for the front end of the processes.
Good. We have a few questions, and I think you've actually answered the first. It asked, does ID tracing that you've described stay with the product for the life of the product when it finally gets shipped to the end customer, or is it erased after the verification step prior to shipping? And I think you have indicated that it's a tool that the customer uses for the product history.
Yeah, no, certainly. Yeah. So, I mean, we transmit the data to our customers, I mean, certainly they can retrieve the data whenever they want. And generally, I think it's within a year that they would actually be able to access the data. But in most cases, we don't delete the data, right? I mean, for automotive, we actually have the data retention in our systems for up to 15 years. Beyond that, I mean, we do have, from time to time requests from our customers to have it, beyond 15 years, but that's more of, again, a commercial discussion, right? But in general, it's up to 15 years that we actually hold on to the data for automotive.
Very good, thank you. Another question, is there any plan to use blockchain to ensure immutability and provenance for the data?
Yeah, I think it has started already, I would say, in terms of traceability in the supply chain. I think essentially, I think in terms of transferring the data, Semi is looking at their task force on traceability. They are looking at using blockchain to transfer the data. I don't know if it has already been implemented because I haven't seen that, and also I'm not sure if it's just the front end that's specific to front end, or is it back end, which includes again assembly and test. But I think there is work that's actually happening. And just to let everyone know on the call that the semi industry has started to look at the whole traceability. I would say probably going back 2018. So it's relatively new when it comes to the semiconductor supply chain for automotive traceability.
Great. Thank you. Another question, if your suppliers are providing die-level traceability with wafer X and Y, are you concerned that the proprietary data is being exposed? And potentially that's from the foundries, I would guess, such as wafer yield. are there efforts to provide the traceability data using, say, data encryption, perhaps to mask sensitive issues such as yield?
Yeah, so I would say this sort of goes back to the previous question as well, right? I mean, how are we transferring the data? What means do we have to transfer the data? Whether would we use blockchain technology and so on? I think, yeah, I mean, at this point, I mean, we do most of the data that we transfer to our customers, or what data that we get from our customers. It's B2B, and it's using SFTP protocols, right? So I mean, those to some extent, yeah, we depend on that. And in terms of whether would we put our customers' data at jeopardy? I mean, again, we have for automotive, we do have quality management system that goes beyond just the ULT, right? So I mean, we always have certified operators or certified equipment and certified machines where some of this data can be stored, or how it can be accessed. So it sort of goes back to what Dr. Renu said earlier, right? I mean, would you have maybe your a threat internally in your companies? I mean, certainly we expect not to, but I mean, in our sense, as part of our QMS, I mean, we do have some of these factors that we use in our factories, right? I mean, whether it's certified operators or equipment or machines that have access to such data.
Very good. Question regarding the unit level traceability for your products. What volume of your FCBGA products are using the 100% unit level traceability, and what are the barriers for adoption of that data by customers?
Yeah, I honestly don't know in terms of what's the volume of FCBGA products that uses unit level traceability. Sorry, I don't know if I can answer that question.
I'm sure a good answer is that you plan to extend it to 100% of products in the future.
Yeah, certainly, right? I mean, when you look at it from an application perspective, most of the flip chip BGA, when it comes to automotive, the end use application is for ADAS processors, right? Whether that's vision processors or central computer, and whatnot. And most of those, as I've said earlier, could be multi-chip modules. One of those areas where you could be using advanced nodes. So certainly, I mean, from our customers' interest, not just have that visibility into the supply chain, but also in terms of what data they can gather. I'm sure there is a lot of interest, and I would say, maybe most of them could already be using today, right? Yeah, but certainly, yeah. I mean, what you said earlier, yeah.
Good. And finally, can you give us a sense for how unit level traceability can be used to improve your internal processes? And is it being used for wafer level packages?
The answer to the second part, wafer level packages, I think it's yes. And how we use this process internally, I would have to take that offline, perhaps.
Very good. Well, thank you for your presentation, Ajay.
Sure.
Yeah. Thank all our speakers today for the excellent presentations and tackling all the questions they got. So thank you very, very much. I also like to take a moment to thank our sponsors once again, Amcor Technology and Advantest. Amcor, as a leading OSAT, has multiple differentiators in the area of technology, quality, and service. Technology in the areas of the advanced packaging leadership, engineering services, and their broad portfolio. Quality through a quality first culture, execution and automation, and service through design and test through dropship, manufacturing footprint, and local sales and support. So Amcor, we thank you. And Advantest, we'd also like to thank, who was recently rated by VLSI Research as the best ATE company in 2020. Very high ratings with a score of 9.5 out of 10 in the various categories: technical leadership, partnership, uptime, commitment, trust and supplier, quality results, product performance, and recommended suppliers. So congratulations to Advantest, and thank you again for sponsoring. And lastly, I'd like to thank everybody for attending. We will have the slides and videos up next week. You will receive an email. But I want to thank everybody for joining us today and look forward to seeing you at a future MEPTEC event. Thank you.